All right, we're going to do example number 3 from this section. It was numbered wrong on my page, so I crossed out the old number and wrote the new one. It'll be correct on yours. So we start with 5.00 liter gas is collected at 100 Kelvin. Then it's allowed to expand to 20.0 liters. What must be the new temperature? So I'm looking for the new temperature. Initially, I had 5 liters, the liters changed to 20 liters. So volume is changing. And I had 100 Kelvin. I'm looking for the new temperature. So that means temperature changing. Temperature is changing. This is volume and temperature are changing. Remember, it's P1 V1 over T1 equals P2 V2 over T2. Well, pressure is not involved. It's just going to be V1 over T1 equals V2 over T2. The nice thing about this is our temperatures are already in Kelvin, so that saves us some time. 5.00 liters is V1. T1, our first temperature, is 100 Kelvin, and it's exactly 100 Kelvin to the nearest whole number. V2, 20.0 liters. And T2 is what I'm looking for. I'm just going to try to find that in Kelvin. So we'll solve for that. V1 over T1 equals V2 over T2. Again, we could derive that from looking at our combined gas law. P1 V1 over T1 equals P2 V2 over T2, except we would be getting rid of pressure in this case, not volume. So we have V1 over T1 equals V2 over T2. You can go ahead and plug these numbers in. My first volume is 5.00 liters. Don't worry about the liters. It's just 5.00 divided by T1, which is 100. V2 is 20.0. T2, that's what I'm looking for. That is just going to be called T2 while I'm solving for it. Remember that we can cross multiply here and multiply 100 times 20, and I can multiply 5 times T2, so I end up with 5.00 T2 equals 100 times 20, which is going to end up being 2,000. And if I wanted to divide and solve for T2, I just divide both sides by 5.00. When we do that, we find that T2 equals 2,000 divided by 5, which is 400 Kelvin.